Sustainable and multifunctional facades. Welcome back. Faced with the global challenges of climate change, increasing CO2 emissions, increasing energy consumption, and material scarcity, the construction industry is rethinking its approach to building design. Tonight we will explore some exciting opportunities in sustainable and multifunctional facade design. From material choice to modular building design to energy efficient and even energy harvesting or adaptive facade elements. Nathan, tell us more about those exciting innovations.
Yes, thank you, Miriam. Let's start with sustainability. The construction industry is responsible for nearly 40% of global CO2 emissions, making sustainable building practices critical for reducing environmental impact. Sustainable facades begin with materials used. Many designers and engineers are now turning to low-carbon, renewable and recycled materials. By minimizing embodied carbon in facade components, buildings can significantly reduce their environmental impact. In addition, facades are increasingly designed with circular economy principles in mind. This means components can be disassembled, reused or recycled at the end of their life. Modular systems and prefabricated panels support this approach, making facades more sustainable and reducing construction waste. One of the most significant opportunities for sustainable facade design is energy efficiency, particularly through advanced thermal insulation. Heating and cooling account for roughly 50% of a building's energy use, so reducing heat loss or gain through the facade is critical. Modern facades might incorporate high-performance materials such as vacuum-insulated panels, aerogels, and multi-layer glazing systems that minimize the heat transfer. These technologies keep buildings warm in winter and cool in summer, reducing energy consumption from HVAC systems. Facades can also enhance thermal performance passively. Features such as shading systems, thermal mass, and ventilated facades prevent overheating and promote natural cooling, especially in hot climates.
Thank you, Nathan. Are there also possibilities to bring the facade into a more active role?
Yes, there are, Miriam. Facades are no longer just the outer skin of a building. They're becoming energy generators thanks to energy harvesting technologies such as building integrated photovoltaics, BIPV, and solar thermal collectors. These innovations transform facades into active systems that contribute to the building's energy supply. BIPV systems integrate solar panels directly into the facade, allowing buildings to generate renewable electricity. These panels can be seamlessly incorporated into glass, cladding, or shading systems, combining functionality with aesthetics. Buildings with BIPV facades can often offset a significant portion of their energy use, feeding surplus electricity back into the grid. While BIPV generates electricity, solar thermal collectors, on the other hand, use sunlight to produce heat. This can be used for water or space heating. These systems are especially effective in colder climates or buildings with high hot water demand, such as hotels and hospitals. Finally, let's look at adaptive facades, where technology meets responsiveness. Unlike static facades, adaptive facades adjust to changing environmental conditions, optimizing energy performance and occupant comfort in real time. Examples of adaptive facades are smart glass, which can change opacity based on sunlight levels, or automated shading systems that respond to the sun's position. These features reduce glare and overheating while minimizing the need for artificial lighting and air conditioning. Some adaptive facades incorporate natural ventilation systems, allowing buildings to essentially breathe. Operable panels or louvers open and close to regulate airflow, improving indoor air quality and reducing mechanical ventilation needs. Advanced adaptive facades even incorporate sensors and AI to monitor external conditions such as temperature, humidity, and air quality. These facades adjust in real time, maintaining optimal indoor conditions while reducing energy use. Back to you, Miriam.
Thank you, Nathan. So, in summary, the opportunities in sustainable and multifunctional facade designs are immense. By using eco-friendly or recyclable materials, or integrating energy efficient or even energy harvesting technologies, or using adaptive facade elements, we can reduce our energy consumption, we can reduce the CO2 emissions, we can reduce waste, and we can conserve our resources. Thank you for joining us here, and stay tuned to learn more about cutting-edge solutions shaping our world of tomorrow.